Okay, let's now see how the last part of our edge to cloud communication data flow works. For that, we have developed a specific pipeline written in Python, and that will be executed in AI Core. So this pipeline will be used to retrieve the energy demand forecasts from the blob storage in Azure. We can have a look at the JSON files we are moving by looking into the Azure IoT platform. We can select the storage accounts, and there we can choose the account and container we have created for the energy grid use case. Navigating through the folders and subfolders, we can reach an example of JSON file. We can download it, and we can also inspect it just to have a look at the format. Here we can recognize the timestamp when the JSON file was created. We can see that we have information about the relative IoT hub and also the device ID. And in the body of the JSON file, we can see the energy demand forecast for the location, the relative location. So if we refer again to our repository, we can have a look at the Python code for this edge to cloud pipeline. So the first thing we can notice is that we are again retrieving the credentials to access an cloud database. These are taken from some environment variables created in the container that will be used to run this code. This is possible again thanks to the generic secrets created in AI Core. And if we scroll down, we see the first method included in this class, where we basically retrieve the JSON file from the blob storage. Again, we have saved as a generic secret the credentials to access the blob storage, and we use some methods from the Azure Blob Storage Client library for Python. Once we have, let's say, downloaded all the JSON files from the blob storage locally, we manipulate these JSON files, we combine them, and here you can see, for example, the information that we can retrieve from the JSON files that you already know from the previous demonstration. Basically, we can create from the JSON files a data frame with this information, the timestamp, the IoT hub name that we are considering, the device names, and then the energy demand forecasts for every hour of the next day. In this part of the code, we use data frames, the pandas data frame to process this data, organize this data in the more convenient way, and then we use HANA ML data frame in order to save the result in a table within an HANA DB. In particular, in this case, we are using, as you probably remember, the underlying HANA DB that we have behind DataSphere. Now let's have a look at the table we have created in DataSphere. We can go into tables, and there we can see, for example, the daily demand forecast table. We can click on it and we can have a look and a preview of the data that we have saved there. You can notice that we have organized the information and we have basically saved the timestamp, the IoT hub name, the device name. We can recognize the same names we have seen before, the hour, and also the forecast, the energy demand forecast that we have received from the by executing the inference with our model on the load data and weather data. This table will be used to create an analytic model in DataSphere that will be consumed through a live connection in SAC. Let's move now to SAC, and let's have a look at the story and the dashboards we have created ideally for an energy planner. So for example, in this chart, we are using the data coming from the table that we have seen a few seconds ago, and here we can have a look at the total energy demand forecast for the next day. The energy planner, for example, can compare this data with the energy that will be provided for the next day, and in case there is a mismatch, he can take action. This is also the information needed to feed an optimization algorithm for the energy distribution that can be used to determine the energy to dispatch to every prosumer one day ahead. We have also added another chart where the energy planner can inspect the details about the forecast for every device and compare them.